Hello folks, this is Mr. Sosa. I am going to do a little video for you guys to help you get going on your lesson for today. That's lesson 231, Never-Ending Story. And we are going to start solving trigonometric equations using the unit circle. I'm going to skip reading over this part here, but you can read that on your own. Consider the equation sine of x equals 1/2. So the way we want to solve this is by sketching a diagram of the unit circle and use it to solve the equation. Okay, so let's go ahead and do that. To sketch a diagram, I'm going to start with a circle, and then we'll say that's the y-axis. Here's the x-axis. Now I'm looking at sine, which we all know to be the y direction, or the y coordinate of my points, right? So sine of y being 1/2, well, that happens right here, oops, right there, and right up here. Why? Because, let me change the color here, because that length right there is 1/2. And you can see right there, that length will be 1/2. So it happens both right there and on this second quadrant. Okay, that's where sine of my angle is equal to 1/2. And remember, I'm looking to create a little triangle like this, a right triangle. Now this is a 30, 60, 90 triangle. How do I know that? I know it because of the length. If this is 1 as the hypotenuse, then that length for sine is 1/2, which is why I drew that little triangle. And now I'm looking for the angle associated with that. Well, if you look at the unit circle, you will see that this angle here created right there is pi over 6. Pi over 6. And then this angle over here is 1/6 short of the whole pi, or 5 pi over 6. So those are two of the solutions where y, or sine, is equal to 1/2, right? Cosine here would be equal to the square root of 3 over 2, but we're not looking at cosine, we're just looking at sine. Okay, so we have sketched the diagram of the circle. Now use a graph to solve the equation. And just like before, with linear equations, we knew how to solve, for instance, x plus 2, and the other equation being 2x minus 1. Where they intersect, that's the solution to these two equations, right? And so if we set them equal to each other, we can solve for x, and then we can solve for y. Similarly, when we want to solve for sine of x equals 1/2, I am going to write sine of x, and there's sine of x in green, equals 1/2. I'm going to do the 1/2 on the second here. Well, I have to actually say y equals 1/2. And so here we have our first solution, pi over 6, which we came up with right there. Pi over 6, that's the first solution. And then the second solution, which we showed right there. Okay, now what is happening, as you can see, is it intersects here, and then it intersects again over here and over there. Okay, so the next question of our problem says, how many solutions does the equation have? Well, looking at our graph over here, you can see it has the 2 that we figured out using the unit circle, but then it has more, and as you can guess, yes, it has infinitely many. So how many solutions does this have? It has infinitely many solutions. Now, to express, a way to express the solutions here, let's let me unclick these guys. And let me pull this back. Okay, we know, let me draw another circle here. Let me draw another circle. Like that. This will be our unit circle right up there. So let's just pretend this is our unit circle. Okay. We know that this angle right there is 0. This over here is pi. And then this is 2 pi. And we are interested in pi over 6 radians. But then what happens when I do a full revolution? I go all the way around. That's going 2 pi degrees, or 360 degrees, to get to the same point. So for my answer of pi over 6, I can actually add 2 pi to that, because that's just going all the way around. That's going from here all the way around. That's 2 pi. But then if I do another 4 pi, that's 2 loops, that works as well. And if I do 3 loops, it should also work. For any second multiple of pi, this solution will work. And so we write it as we did with the domain of tangent, 2 pi times n. And remember, n should be an integer. And over here, I'll let you figure this part out, but for 5 pi over 6, again, if I add 2 pi to this, I just end up at the same place. If I add 4 pi to it, 6 pi. So any double multiple of pi, in other words, 2n pi, should give me this solution. And so these expressions right up here, this one on the left and this one on the right, represent all the solutions on these graphs here where they intersect. And of course, there's infinitely many, because there's infinitely many integers. Okay, I hope that makes sense there, folks. That's answering problem E and D, right? To express all of the solutions, we use this notation, if you will. Okay, so the solution for here we can write actually let's write it on over here. So the solutions would be x equals 5 pi over 6 plus 2n pi, and also x equals pi over 6, and again plus 2n pi. Okay. Now we want to do a similar approach to solve problem 122 here. Except now we're looking at cosine, whereas cosine equal to 100. And again, we're looking at the angles. This is interesting here. Sine of x equals 2. In essence, does sine intersect the line y equals 2? And we can go over here. Let me get rid of this and mute these guys for now. So actually, I'm going to need sine of x and y equals 2. Do they intersect? Does sine of x intersect with y equals 2? No. I'll let you figure out what that means. How many solutions does that equation have? Okay. Over here, solving like you would any other thing, move the 2 first to the right-hand side, right? We wouldn't want to do the arc cosine, although you can if you want to. But building this unit circle will be helpful. Anyway, I have to go, guys. So I hope this was helpful. I left the answers with the teacher, the substitute teacher, and I will see you all tomorrow.